In this video I'm going to show you a couple examples of how to add multiple vectors together when they're not at right angles. So we saw in class already that if we want to add vectors we have to put them tip to tail. So let's say we have a vector like, oops, scratch that. Let's say we have a vector like this and another vector that's at a slightly different angle. So we saw how if we look at their components, the components of each one will add up to create the components of the resultant. So there's the y and the x component for the first one, and the y component and the x component for the second one. So if we wanted to find the resultant, that points from the tail of the first one to the tip of the last one. Alright, that's a little better resultant vector here. So our resultant vector in blue points from the tail of the first vector we drew to the tip of the last one. So then we can see this blue vector, our resultant, we'll call that R, has x and y components also. And the x component of this one is simply these two x components added together. Same with the y component. That would be this y component plus this y component. So we can extend this reasoning to any situation with any number of vectors. So let's call this one we're calling R for the resultant. Then this would be R sub x and R sub y for the x and the y components. So we could name this one A, and this one B, then this would be A y because that's the component in the y direction. This would be AX, this would be BY, and BX. So then in general, for an addition of any number of vectors, we could say that Rx is equal to AX plus BX plus CX plus however many vectors you have, all their x components added together. And then Ry is same thing, AY plus BY plus CY plus dot 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 dot. And then to find the value for R, then you can just use the Pythagorean theorem, where R would be the hypotenuse. So R squared equals Rx squared plus Ry squared. Okay, so let's look at another example of where we can use this logic again. Let's say we have two vectors. Vector A, so new problem here. Vector A is 8 newtons at 60 degrees north of east. And vector B is going to be 4 newtons at 20 degrees west of north. Okay, slide this up a little bit. Alright, so all we need to do is find the x and the y components of A and B so that we can add them together. So let's do A first. So first it may help to draw out what A looks like. So A is 60 degrees north of east. That means east is going to be our reference line that we make our angle with. And then we draw our line 60 degrees pointing toward the north of that line. So that would be something about like that. So this would be our 60-degree angle. It points 60 degrees to the north of east. So then our components would lie along the east and the north. So this would be A, and that's 8 newtons. And this would be AY and AX. So to find the components we need SOHCAHTOA. AX is adjacent to the 60-degree angle, so if this is our theta, we can use cosine. Cosine of 60 degrees is adjacent, that's our AX, divided by hypotenuse, that's our A. So if we multiply both sides by A, then A cancels from this side, we get AX equals A cosine of 60 degrees. And that works out to be 4 newtons. Okay, now we need to find AY. So AY is opposite of the angle, so we can use sine. Sine of 60 degrees equals opposite, which is AY, over hypotenuse A. So then AY is going to be A times sine of 60 degrees. So when you solve that, you get 6.9 newtons. Okay, so now we have AX and AY. We're halfway there to building our right triangle for our resultant. Now we need to look at vector B. So vector B, let's make a line here, is 20 degrees west of north. So that means with respect to north, the second direction that's listed, we're going to draw it 20 degrees to the west of there. So that would be this direction. So this angle would be 20. This is north and west. Those would be our components. So here's our B, this is BY, and this is BX. So one important thing to note here is that BX is going to be negative because it's pointing now in the negative x direction. It's pointing the opposite way of AX. So when we add these two together, we need to add BX as a negative value. So this time our x component is opposite of our angle shown here. So we need sine. Sine of 20 degrees equals bx divided by b. So then bx is b sine 20 degrees. And so bx works out to be negative 1.4 newtons. We have to add that negative because of the way we've drawn our picture. By is then going to be b cosine of 20 degrees. That works out to be 3.8 newtons. So then to put our triangle together to make our resultant, we just need to add AX plus BX to get RX. So RX equals AX plus BX. That means it equals 4 newtons plus negative 1.4 newtons because our BX was negative. So Rx is 2.6 newtons. Ry is AY plus BY. Here's our BY. So it's 6.9 newtons plus the 3.8 newtons. So we get Ry is 10.7 newtons. So these two now make up our new right triangle. These are the legs of our new right triangle. So let's move up a little bit. So Rx is going to be 2.6 newtons. And since that's positive, we know that's pointing toward the east or our positive direction. And then our y is 10.7 newtons to the north because that's positive also. So then this will be our r. So then we can use the Pythagorean theorem. R squared equals 10.7 newtons squared plus 2.6 newtons squared. And r works out to be 11.0 newtons. So that's the magnitude of our resultant. To fully describe this resultant, we also need the direction. So we need to find this angle theta. That's the angle that the tail of the resultant makes. So to do that, we could use tangent. Tangent of theta equals opposite over adjacent. So 10.7 over 2.6. That works out to give us a theta that equals 13.7 degrees. So how can we describe this? Alright, that doesn't seem quite right looking at our picture. I realized that I did my math wrong. This should actually be 76.3 degrees. Okay, so our theta here is 76.3 degrees, and that looks more to scale relative to our picture. So how do we describe that with reference to these directions? Well, that's the angle that our vector makes with east. What direction does our vector point from east? It points toward the north. So this is 76.3 degrees north of east. So then these two pieces of information together make up our answer. This would be the magnitude of our resultant, and this would be the direction.